two robots. Let's say robot A right now performs a scan. He's going basically from 0 to 90 degrees in 15-degree increments. Now, in order for the robot to stay still, we had to inject a position on the first scan that would relate to a possible object. And that object we inserted at 30 degrees. Once the scan is completed, it picks up the object at 30 degrees. The robot technically moves forward 2 centimeters and then turns to the possible object location and reads a distance measurement. It computes the measurement that the object should be at using trigonometry based upon the motion in the y-axis moving forward. Robot B is doing the same thing, but it's offset by a certain XY amount that's hard-coded into the robot itself. The robot, again, does a sweep from 0 to 90, and it too has an object inserted at a specific distance that tells it that there may be a possible object there. The robot moves forward 2 centimeters and then turns its sonar to that calculated distance using an algorithm to see whether or not that object is truly there, and that process is called verification. If the measured distance between the sonar and the object is verified, it then transmits using the XBee chip over to the base station. If that calculated distance does not match the measured distance, then there is no transmission and the whole cycle begins again. Now, we had to insert a specific distance on the first scan because right now the robotic motion is not that accurate, and as far as the sonar measurements were not that accurate either. So we would have to deal with the inaccuracies of motion and the inaccuracies of the measurement, and right now for what we're doing would be too great of an error correction. So by keeping the robot still, we're able to say, in theory, everything is working. Now to put it to practice will be our next step.